Assalamualaikum, Aidan. So today we're going to talk about introduction to operating system. So operating system is how a computer is put together, how it works, and let's get started. First up, the operating system or OS is like the boss of your computer. It has parts put together. Let's do the things that you like, that playing games and write documents. What makes your computer do what you want it to do. So now let's look at how a computer is organized. Think it's like a puzzle. There's a main part called the CPU that does the thinking, memory, and remembering things, and also storage for keeping your file. Plus there are things like keyboards, screen, so you can talk to your computer, and then lastly, with a computer architecture. This is like a plan for a building. First, there is the hard stuff like wires and things. Then the OS as the middleman between the hard stuff and the things you want to do. Finally, you have your program and apps that you write, play, and draw. So with the operating system in charge, well-organized computer and a good plan, you can do amazing things.
Here, a description for both computer system architecture and operating system operations. Computer system architecture is the blueprint that defines how the hardware components of a computer are organized and how they interact. It encompasses the central processing unit, CPU, memory, storage devices, and connections between them. Understanding this architecture is crucial as it determines a computer performance and capabilities. In modern systems, the CPU is the brain of the computer, executing instructions and performing calculations. Memory provides temporary storage for data and instructions, while storage devices like hard drive and SSDs offer long-term data storage. Buses and interconnection facilitate data transfer between these components. By comprehending computer system architecture, you can optimize hardware utilization, improve performance, and troubleshoot issues efficiently. So, for operating system operations are the core functions that enable an OS to manage the computer effectively. These operations include the process management, memory management, file system management, and input-output operations. Processing management involves handling multiple tasks simultaneously, scheduling processes, and ensuring fair CPU allocation. Memory management ensures efficient storage of RAM and virtual memory, allowing multiple processes to coexist. File system management deals with storing, organizing, and retrieving files efficiently. The OS manages file access, permissions, and data structures. I/O operations control communications between hardware, device, and software, enabling data transfer and user interactions. Understanding these operations is essential because they determine how applications run, how resources are utilized, and how the system responds to the user command and task. Operating system ensures that everything works harmoniously, making your computer user-friendly and efficient.
Thank you, Aiman. So for me, I'll talk about computer environment. There are 6 types of computer environment. Firstly, traditional is a standalone general-purpose machine but built as more systems interconnected with internet. Second, mobile. For example, handphone, tablets, and app. Mobile has extra features than traditional such as GPS and gyroscope. Mobile now are being led by Apple iOS and Google Android. Thirdly, client server. It can be classified into 2 types: compute server system and file server system. Next, peer-to-peer system. In a peer-to-peer environment, devices communicate directly with each other without the need for a centralized server. Cloud computing is the 5th environment. Cloud computing has many types such as public cloud, private cloud, hybrid cloud, which is a gabungan of both cloud, software as a service, platform as a service, and infrastructure as a service. Last but not least, real-time embedded system. This system is the most prevalent form of computers right now. Next subtopic, free and open source operating system. Operating system is made available in source code format. counter to copy protection and digital right management. For example, Linux and BSD units. And the last subtopic to be discussed is kernel data structure. It has three types of linked list, which is singly linked list, doubly linked list, and circular linked list. It also has binary search tree. The number in the right branch has to be greater than or equal to the number in the left branch. Also, hash function can create a hash map. Lastly, bitmap is a string of n binary digits representing the status of n items. That's all from us. Thank you. Hi, resource management. Resource management is one of the primary responsibility of an operation system. It involves the efficient allocation and utilization of the hardware resource to ensure the multiple process. And the application can run currently without interference. The first one is CPU scheduling. The operation system determines which process should have access to the CPU at any given time. It uses scheduling algorithm to prioritize and allocate CPU time to process fairly and efficiently. Second is memory management. The operation system allocate the managed memory resource to process. It ensures that each process has its own address space and cannot interfere with the memory of the process. The third is the file system management. The operation system provides service for creating, reading, writing, and management, filing, and directories. It's handled by input-output operation. The fourth management is file management and device management. Operation system manage hardware device such as printer, disks, and network interface. They provide device drive and handle input-output operation. The last one is resource synchronized. The operation system implement synchronized mechanism like semaphore and lock to prevent conflict between process when access share resource.
Alright, now let's talk about two fascinating concepts in computing, which is virtualization of operating system and distributed system. The first one, virtualization. Virtualization is a technology that allows you to run multiple operating systems on a single physical machine. It's like having several computers within one. Each of these operating systems, called virtual machine, operate independently and they are isolated from one another. This means you can run Windows, Linux, or even different versions of the same operating system side by side on the same hardware. The benefits are immense. It optimizes resource utilization, reduces hardware costs, and make management and scaling of IT infrastructure become more efficient. Now, let's talk about distributed system. Unlike virtualization, which focus on a single machine, distributed system involve multiple computers working together as a single system. Each of these computers or nodes has its own processing power and memory, and they communicate with each other to achieve a common goal. This could be anything from web application to large-scale data processing. Distributed systems also offer high availability, fault tolerance, and scalability. They use in everything from cloud computing to social media platform. So whether it's optimizing resource with virtualization or harnessing the power of multiple machines with distributed system, these technologies play a crucial role in modern computing. And there you have it, a quick overview of virtualization and distributed system. Thanks for tuning in.